Welcome to this session Techies. My name is Yogesh Kumar. In session today we are going to talk about configuring kernel based virtual machine or KVM on a system running Red Hat Enterprise Linux or CentOS 7. So this is step-by-step procedure. First thing, what is KVM? So KVM stands for kernel based virtual machine, and KVM is a virtualization infrastructure for the Linux kernel that turns it into a hypervisor. KVM is available after kernel 2.6.20, and KVM require a processor with hardware virtualization extensions. I've listed a couple of pros and cons of KVM. The benefits are it's scalable, means once you allocated or created a VM, you can scale it. You can add more processors, memory, or disk space. Then very lower cost because you need a physical server only. Above that, KVM is part of Red Hat and CentOS packages, and it don't need separate license. It is secure support, and it supports live/offline VM migration, means you can migrate VM from one system to other, and that's a full virtualization. That's not a para virtualization, so you can use HVM. And next benefit, no vendor lock-in contract. What it mean? Because you are owning your VMs and this KVM stuff, so you are not depending upon any other third-party vendor. So no lock-in contracts. I've listed two drawbacks. One, let's say you are not having any clustering system. So if your physical system dies due to XYZ reason, like all the VMs hosted on that particular system will go down. So that's a drawback. In case you have clustering where VMs can float between systems, then there is no risk. But again, with a single system, that's a risk. And with KVM, networking is a bit complex. That's my own experience. I'm not sure like what's actually enterprise experience, because this setup is only for lab. I have created. So to me, like I have faced networking complexity. Okay, what are the prerequisites for configuring KVM host? So KVM host is a machine which will be turning into a hypervisor. Okay, so we need a system with VT, means virtualization extensions, and we need Linux OS with minimum kernel 2.6.20. So in this setup today, I'm going to use CentOS 7 machine as my Linux host, and system with VT, I'm going to use VMware Workstation, where I have enabled VT extensions. Let me show you how VT extensions looks like. If you're running system on VMware, how you can turn the VT extensions on. Let me show you. So I'm just editing, clicking on settings, and if you see, this is the VMware virtual machine, and in processors, this is the bit which I have already ticked. When you're creating a machine, just tick this one, which is virtualized Intel VT XPT or AMD RVI. So that's it. Just save it. It means your VT is enabled. Okay. So now I've listed couple of steps. On a OS operating system side, you can check whether VT is enabled or not. Like this is the way. Just grab this particular keyword SVM and VMX. One is for Intel, one is for AMD processors, and this is the output which I got on my system. And after that, you have to install your KVM packages, like step number 2, and enable the libvirt services. Then you have to configure network for KVM. You have to configure your physical interface. In my case, it is IT1. And after that, you have to configure a virtual bridging interface. So this interface is a bridge which is using netting with the virtual interfaces. And then you have to enable IPv4 forwarding in this way. I'm just telling you theoretically. I am going to do these steps practically in front of you. After that, you have to load the modules or the configuration you just added into sysctl. After that, you have to update your network configuration file, so you can choose or use your desired IP range, because by default it comes 192.168.122.1 something, but I believe you don't want to stick with that one. You want to use your own enterprise or custom ranges, so you can update this file. And after that, you have to add a route, that's a network route, to enable communication with your virtual machine. and then you have to restart your KVM host or Linux server. Then that's it, friends. After that, you can create guest VMs. So this is the way like to create a VM. I will discuss this when I'm doing the stuff. And these are common KVM management tasks, like how to list VMs, how you can display VM information, means how much memory it got, what is the configuration, what is the virtualization type, what's the OS. To stop a VM, shut down it. To start a VM, start it. Enabling auto start. And if you want to take console, like this is the way you want to delete a VM. This is the way if you want to clone a VM. This is the way. Cloning is useful. Let's say you got one VM, which is your SOE image. Let's say that's SOE. So from that one, you can clone multiple VMs as per your requirement. So what's the benefit? In that way, you don't need to set up each VM according to your SOE recommendations in your setup. So you can use cloning. So that was theoretical parts, friends. Let's begin with technical session now. So let me open one putty session. I am on my Linux system, which is CentOS 7. Let me show you. Enterprise Linux 7. And let's cat tc CentOS release. This is CentOS 7.3, which is latest one. So first thing, as I mentioned, we have to check whether processor supports VT or not. So grep SVM or VMX from proc CPU info. If you see you got output, it supports VT. So that's a good thing. That's a first requirement which is met. And if you see kernel, as I mentioned, 2.6.20 or above, this is 3.10. So this definitely supports KVM. Next thing, we have to install KVM packages. These packages are part of default repos. Let me show you repo configuration on this one. Okay, so internet speed is a bit slow today. I'm not sure if it will take some extra time. Okay, if you see these are the repos, and it got extra packages or EPEL repo. So I'm installing QEMU KVM, libvirt Python, and libguestfs tools and virtual install. So saying yes here. If you see, it got a big dependency list. So that's a long list of packages, and it is getting installed now. And they are mostly part of base repository. Meanwhile, on my system, I have disabled SE Linux. So if you want to use SE Linux, you have to do little bit extra, like to manage SE permissions. But I'm not using. This is my lab setup. Okay, friends. So packages are installed. Next thing, we have to enable libvirt service. To enable systemctl, enable libvirt. Pressing enter, and then I'm going to start libvirt service now. So service is started. Let's check status. If you see, service is running and enabled. So that's good. This part is done. And next thing, friends, we have to configure networking for KVM. So as I mentioned, I got two interfaces on my system. One is H0, which is for my local network. H1 with the internet connectivity. This is connected to my broadband router, and the backend is Wi-Fi interface. So that's internet connectivity. And after installation of virt packages, I got two neonics, var br0, which is default, and by default it gets IP 192.168.120.1. I'm sure you don't want to use this range, but I'm going to cover how you can update the range. And this is the virtual bridge NIC, which comes by default after installing packages. So first thing, we have to update our Ethernet configuration file for H1, because H1 is the interface which we are going to configure as bridging or using for bridging. So I'm doing vim H1. So here, first thing I have to do, I have to get rid of these IP address, netmask, and gateway, because this will go to bridging interface. So I'm just deleting or comment. Let me comment these lines in case we need it in future. Okay, so I have commented these lines, and I have to add another line which is bridge is equal to over br0. It's bridge brdg. Sorry, my mistake. Okay, so we have updated bridging configuration here. That looks good. Saving. After that, we have to create another file where we will save our bridging information. Okay, so let me do that. So vim this file, or let me copy this file, which is our it1 to vir br0. Okay, so it's copied. Let's edit this file. So in this file, entries will go, this is type is bridge because that's a virtual bridge interface, BRIDGE, it's bridge, and it don't need any hardware address because that's virtual, and boot proto none is fine. Name, I don't need name, so that's fine. On boot, yes. IP address, we need IP address, we need net mask, we need gateway, and after that device, basically we need a device, means which device it have to use. That's a virtual bridge 0. Okay, so looks good to me. Let me save this file now. Okay, so this is done. Now we have to enable IPv4 forwarding. So friends, by default when the word packages get installed, it creates this file. So let me show you with which package it got delivered. So libvirt daemon. So in this file, that's a systemctl file. We have to add IPv4 forwarding entry. To add it, I got this entry. Let me add it right away. So entry added. Let's write changes and enable changes. Oh, what's error? Systemctl -w. Okay, that's my mistake. Let me do it here. Okay, so it's enabled. Okay, next thing we have to do, as I mentioned, because when virtualize or virtual bridge interface gets created, if you see its IP range is bit odd. I believe you don't want this range, you want to use your custom range. In my case, I'm going to use it1 range, which is 192.168.1.0 to 254. That's a /24 network. So to do so, you can add it this particular interface using verse netedit default. This is default interface, which automatically can. That's why it is default. So editing it. So here, what you have to do basically, you have to change this IP to your actual Ethernet IP, which is 1.140 in my case. Okay, because this is the interface which will be used for bridging, and this is the DHCP range. Let's start it from 1.0, and it will end on 254. Okay, so looks good to me, and that's a DHCP. If you see, that's a DHCP range, this particular bit. So you can use or choose your custom DHCP ranges depending upon your requirement. So save this file. It is saying it gave me some error. Start of range. Okay, I go towards error. So here I have to start after 140. Let's start from 200. Basically, you can set the IP to 1.1. After that, you can use IPs from 1.2 because this IP is reserved now. So right quit. Okay, this is done. Next thing, to make routing work between your physical machine and the virtual machine, like basically network communication between both systems, you have to add a route. To add a route, you can create a route file for virtual bridge 0. And in this route file, I'm adding this particular entry. What it mean? Any traffic which is coming from this network should be route via 140, which is our IT1 IP, which was our IT1 IP. Now it's a VIR BR0, Virtual Bridge 0 Interface IP. I'm sure like it may be getting confused, but again that's a bit dodgy thing. Okay, so friends, configuration is done. Let me restart my server. Then with one server we will start creating virtual VMs. Okay friends, system is booted. I am on system again. So let me clear my screen. Let's check status of VRD service. System CTL status lib VRD. If you see service is running and it's enabled, that's good. Okay, next thing we have to check our interface configuration. If you see here, IT0, as I mentioned, that's a local network. IT1 right now it not having any IP, but it is used for bridge. It is underlying interface for bridge, and this is our bridging interface. If you see that virtual BR0 NIC already gone, because that's no more exist. If you see virtual bridge go to this particular IP in our range now. Earlier it was 122 dot something. So that's good. We got our own IP range applicable now. So let's check whether DHCP range is still there after reboot. If you see that's our DHCP range, that's there. It means all the changes worked well, and after reboot they are persistent. Okay, so now next things we have to install or create a virtual machine or VM, or you can say some people call it KVM guest. So I got one file here. Let me show you ls-l/temp/cent. So this is ISO image of Red Hat. Red Hat or CentOS 7. That's a CentOS 7 ISO image. So first thing I have to permission it 775. So other users can, if you see by default it got some only for group permission, but not owner or others. So I'm just changing it to 775. So system processes and installation daemon can read it. Okay, so this particular bit is done. So first thing friends, we have to check what operating systems can be installed on this system. Means what on the virtual guest, or which virtualization or operating system this KVM is supporting. To do that, you can run os info-query space os and pipe it to more. Okay, if you see this is the short ID, this is the name, like ALT Linux version this one, ID this one. So let me make it a little bit lower size so you can read it properly. If you see, okay, this is still big. Let me make it a little bit smaller. I'm sure you will not like smaller things because on screen. Okay, so these are the Linux versions which are supported. CentOS 6.7, 7.0 is supported. That's good. We are going to Debian is supported. After that, Fedora is supported by KVM, and FreeBSD supported, Mendrix supported, so on friends. RHEL supported, Solaris supported, Ubuntu supported, Windows supported. If you see Windows 2K12 or 2K3, Windows 8, Windows XP. So friends, it supports many operating systems. Okay, so we are going to install CentOS 7. So we have to use CentOS 7.0. If you let me grab CentOS 7.0, pipe grep -i CentOS. So we are going to use CentOS 7.0. So this is CentOS 7.0, this one, and this is the name. So while mentioning in command, I have to mention this name, which is the name for this particular OS here. Okay, so next thing, to create a VM, basically I have created this particular additional mount point with the 12 GB capacity, and right now it's not used, nothing here. Okay, so first thing I have to do, I have to create a VM. So to create a VM, let me name it test VM1, and let me put command which I have already prepared. I can explain what this command means. So word install is the command, followed by -- network. That's network is bridge, use vir br0, which is our virtual bridge now, dash dash name. So name this container as test vm1. OS variant is CentOS 7.0, this one which I just explained you, this one CentOS 7.0. So if you're installing Windows, you have to mention Windows. Dash dash RAM is equal to 1024, that's an MB, so it got 1 GB RAM. And vCPU1, disk is path. So path mean it will create in this directory this file testvm.img, and size will be 4 mean 4 GB. So it will automatically create a 4 GB disk with this name. Graphics none, because I'm installing Linux, so I'm going graphics none, so it will be not using any graphical thing. And location mean the media location. So right now I'm using this particular ISO, so I have specified path. So ISO image in /temp, so I have to update path here /temp. Okay, that looks good now. Extra arguments like console is TTY, means it will use this console and console. These are console settings, that serial console particular baud rate. Check all of what it mean. In case file already exists, that's a complementary, no need to use this one, I'm just getting rid. Okay, so friends, this is our command. I'm running this command now. So if you see, it allocated a particular file with 4 GB size, and installation started, friends. So your CentOS installation started. Now you have to follow normal process like you're following to install CentOS. So if you see on screen, installer started and it is installing CentOS 7. So these are options: language, installation source, destination, network configuration, user, time zone, software, kdump, and root password. So that's installation will go command line. If you want to use graphical way, you can install X-Window packages, because I don't prefer those on enterprise system, but you can install it and you can run installer using graphical way. So friends, you have to continue with this one. So I'm not going to record this thing, because that's something easy thing you can do at your level. So once your installation is completed, you can run you can configure your virtual or guest operating system as per your enterprise setup. So that's it, friends. Okay, so let me show you how you can manage virtual machines on your system. I'm going to just explain a couple of commands, not everything. To list what all virtual machines are on your system, just run virsh followed by list -- all. This command will tell you any running VM or stopped VM. So this is the CentOS VM which we just installed, and I have just paused my video. I have configured it, basically installed, created file system, installed packages, and performed little bit configuration which I need. So this VM is running. So let's say you have to get domain information. Basically this is domain. So virsh dominfo and VM name. So it will tell you about your VM. Its ID is 1. If you see this ID bit, this is the name, this is the unique ID, this is the OS type, that's HVM, that's a hardware virtualization. So that's a complete virtualization. State is running, 1 CPU. This is the CPU time usage. This is the memory allocated, which comes to 1 GB. Persistent, yes, that's a persistent VM. Auto start is enabled. Manage, save, no. Security model, none. And this is DOI. Okay, so next thing, let's say you have to shut down this particular machine. How you can shut it down? Or shutdown followed by your VM name. Press enter. So you have seen message, it is getting down now. Okay, so other thing, if you have to check what's going on console, to take console you have to run virsh console followed by the ID. This is the ID 1. Press enter. You see it's saying domain not found. Oh, it's taking I believe this is the VM name. So domain is not running. That's true, because we have shut it down. That's why we are not able to take console. So let's run list all. If you see, that's a shut off state. Right now it haven't got any ID. So let's start it. To start it, you have to run virsh start and your VM name. because there is no ID currently, because that VM is down, you can't mention ID. So was start, it started. Let's take console of this VM and see what's going on. So if you see that VM is booting, so that's a boot process of that VM. So in that way you can take console, and using escape characters you can get rid from console. Okay, so that was console, and let's test how we can clone a VM. So watch list, it's running, so let's shut it down first. So let it come down. Okay, if you see it is not listed here. Why it is not listed? Because I have not used --all, otherwise it will only show the running VMs. If you see, now it's down. So next thing, we have to clone the VM. So for cloning, I have powered off my VM. It's better, source VM basically. It's better once your source VM is powered off, then only do cloning. Otherwise, you may clone a broken system, so that's not beneficial. So how to clone? Word clone, the disconnect QEMU system. Original will be your source VM, which is test VM1. Target is name test VM2. -f is the new file, which will be a OS or operating system store for a new VM. So I've named it test vm2.img, which is same name to test VM2. So it is getting cloned now. It is getting allocated. Let it finish. If you see in my screen now, cloning is completed. It gave message clone test VM2 created successfully. So let's test the VMs. Wash list followed by --all. So now we have two VMs. Okay, so that's a way, like you created another VM with similar or same to your existing VM. So let's power on both VMs. Basically on your test VM2 you have to change or update the IP address and hostname, because it's a clone, so all information will be similar to your clone. So I'm not booting test VM2, or I can boot test VM2, so that not matters. Let's boot one VM, and I can show you how connectivity works within VM, basically network connectivity. So wash start the VM name, pressing enter, it will boot the operating system. Okay, it started and it will automatically boot the OS. Let me take console. Wash console, the VM name. Let it boot. Once it booted, I can show you how connectivity works within VM. And as I mentioned, I am using DHCP to allocate IP to VMs. But that's up to you. You can use a static IP configuration. Procedure is a bit different, but I will prefer DHCP. Virtual VM is up. I have already named it AWS CLI lab. Let me log in, root 123. Okay, so how network within VM, if config -a, if you see it's 0 is created and it automatically got IP. Okay, and next thing, let's check network connectivity, nslookup, google.com. So nslookup is working. It means this VM is connected to internet. Let's check routing table. Sorry, netstat. Okay friends, if you see, I have added this particular IP, which is my broadband IP, as a router. So that's the way communication is happening, and my guest is able to communicate to net. So that was the explanation how you can install KVM host, how you can configure it, how you can configure network on KVM host, how you can create a VM, how you can clone a VM, and I have discussed a little bit about common tasks to start, stop VM, and take console. So thanks for watching this friends. If you have any query or any suggestion, just leave a comment on my YouTube channel. Do subscribe to channel if you want to stay updated with the latest coming videos. Thank you. Bye bye.